Hello and welcome to the second video in our tutorial series on TypeScript. In this video, we will cover a lot of content under the general heading of basic types. We'll create a project folder, move into it, initialize it as an npm project, add TypeScript, add TypeScript tsconfig.json file, add ESLint, open our project in Visual Studio Code, add an ESLint RC file, add scripts in our package.json, add a source folder, and add a main.ts file inside of that. We've covered all of these steps in a previous tutorial that I will link to above. And with that, we are ready to get coding. JavaScript and TypeScript predominantly use the C++ style of comments where a double slash indicates the beginning of a single line comment and the rest of the line is a comment, or you can use this fashion to have a multi-line comment. You can also do more structured comments using JSDoc, XML documentation, etc., which parse out the comments to make meaningful information out of them. The important thing with comments is to use them copiously in your code. It might not seem meaningful when you write that code, but you will appreciate yourself a ton when you come back to that code maybe 6 weeks later. There are mainly three types of basic literals in TypeScript: the number, the string, the boolean. There are also literals for arrays, objects, etc., but we will come to them later. So let's try running this basic code. And there we have it. Next up is constants. Now the interesting thing about constants is if you hover over the variable x, the constant x here, the type of x is not number, it's actually the literal 42. And the type of y is actually true and not just boolean. So for example, if you write this statement will work in another programming language, but in TypeScript, this is a compile time error because we know at compile time that this can never be true. Also note that we use the const keyword for defining constants. Here, the type of I becomes number and the type of str becomes string because we use the let keyword to define a variable. TypeScript also has the typeof operator to identify the type of a given variable. So we can see that I is number and str is string using the typeof operator. Variable name requirements in TypeScript must start with a letter, underscore, or a dollar sign is also allowed. Can contain letters, underscores, dollar signs, or numbers. And in general, avoid conflicts with language keywords or reserved words, common identifiers, etc. It's good practice to use longer names which are more descriptive for your variables. There's also the var keyword in TypeScript just as in JavaScript. With var, the difference is you can redeclare a variable multiple times. Within the same scope, the variable must have the same type, but in a different scope, you can redeclare it with a different type as well. So here on the second line, we are redeclaring var1 again with the same type, and that's fine. Inside of a function, we redeclare var1 as a boolean, and that is also fine as long as it's in a different scope. If we run this code, we now have the output of boolean because the type of the inner declaration of var1 is boolean. However, the type of the outer declaration of var1 here still continues to be the number type because of it being outside of the function scope. So as a general recommendation, do not use the var keyword. It kind of defeats the whole point of TypeScript and brings us back into the JavaScript world. We have the boolean type in TypeScript. It can have values true or false, and you can use it in conditionals such as the if statement that we have here. And so this will actually print this because my bool is true here. Let's examine the number type in TypeScript. We are printing 10 by 0. In a language like C or C++, this would cause a segmentation fault, but TypeScript and JavaScript actually have a value infinity. You can use infinity as a literal in your code. There is also a negative infinity. You can compare infinity to another infinity value, and it will return true. But what happens if we multiply infinity by 0? We actually get a value NaN, or not a number. Not a number is a little bit strange in that two not a number literals are not equal to each other either. They cannot be compared. We got two falses here. We can use these functions isFinite and isNaN to check if a value is either not a number or if it is a finite. So it has to be not a number and not infinity or negative infinity either. Hexadecimal numbers and exponent notations are also supported in TypeScript. So this hexadecimal number is the same as 17, and 1e3 is 1000. Exponents have to be integral values. Strings in TypeScript can be enclosed in single quotes or double quotes. You can also use the backward quotes to include other values programmatically computed inside of your string. So this will print the value of x, which we previously declared somewhere up above to be equal to 42. Escape sequences using backslash are supported. Here we print hello world on one line, then we print hello world on the next line, but use the backslash r to take the carriage back to the beginning, causing the HEL to be overwritten with SAD here. Unicode strings are supported. For example, this escape sequence will cause the Malayalam character SHA to be printed onto the terminal. Strings in TypeScript or JavaScript are immutable. You cannot change a character in place like in C++, for example. Replacing characters results in a new string. Also, there is no character type. A character is a single character string in TypeScript. Regular expressions are also types in TypeScript. And you have a regular expression literal format, which is preceded and terminated by the slash character. In this regular expression, we are looking for, starting at the very beginning, optional plus or minus sign, followed by at least one digit, followed by an optional sequence where there's a dot followed by at least one digit. And that should be at the very end. So we are looking for numbers basically. And if we run this returns true because this plus 123.5 is a number that matches this regular expression. There are also other things in TypeScript and JavaScript that have literal formats, for example JSX. We will cover these in future tutorials. Functions are also types in TypeScript. For example, here we have a function add1 which adds two numbers, and we use a console log to print that result. So we get 8 here when we add 5 and 3. The add function can alternatively written as we have add2, which is assigning a function to a variable, and it does the same thing. If we run it, it can add 5 and 3 to give us 8. We can compare functions just like other values. Here we are comparing our add1 and add2 function, and both of these will return false because these are not equal functions. The triple equal to and the double equal to, one is the equal and the other is the identical operators. We will come to operators in a later tutorial. We should remember that function type is not just one type. There are different function types based on the signatures that we are using for each of the function. We also have this handy return type generic, which can take the type of a function and give us the return type of that function. So for example, our add2 function returns a number. So when we create a variable named addResult using the return type of add2, the variable type for that is number. TypeScript has this notion of a union type. So for example, our string or bool variable has a type of either string or boolean. And we are assigning a string first, but then we are assigning a boolean to it. And this is also okay because this variable is of type string or boolean. It's kind of weird. It exists because TypeScript is built of JavaScript, and JavaScript doesn't have types, so TypeScript needs to accommodate functions that can return mixed type content, and there needs to be some way of expressing their return type, etc. TypeScript compiler does try to be smart. For example, here we have string or boolean actually holding a boolean and string or boolean 2 holding a string, and so the compiler does complain that this can never be true. But it's kind of limited when you have nested functions and things being checked deeper down in code, etc. The compiler is obviously not able to keep track of dynamic type. And so because of that, here we have a function where we are doing the same comparison which previously caused a compiler error, but now this compiles fine and it compares string or boolean to string or boolean true and gives us a false. It is also possible to do union of, for example, a refrigerator type and a car type. Does it make sense in the real world? No. So remember that this exists because underlying JavaScript is typeless, but avoid using unions where possible. As a further demonstrative example, for example, somebody thinks they're smart and want to create an add function which can add two numbers or concatenate two strings. So I'm going to have a number or string union type for my parameters and my return type. And then if the type is number, I add them. If the type is string, I can add them. But this has a problem. The compiler complains that you are not returning a value in some situations, especially if you pass a number on one side and a string on the other. You can avoid this by catching and throwing an error in this situation. Like I said before, there isn't a good reason to use union types other than JavaScript. For example, if you have a salesman class, you can argue that a salesman can sell a car or a house, but that's really a problem with your object model. You can have a salesman, which is a base class, which has a car salesman and a real estate agent, which are derived classes. The car salesman sells a car. The real estate agent sells you a house. The good programmer goes with a better object model. When you're overusing union types, it is indicative of something wrong with your object model. TypeScript has a never type. In our add example before, we have an exception if we have a string and a number being passed in as a parameter. We can make this a little bit more explicit by adding the optional never. This is saying there is a possibility that this code will never return because it throws an exception. Some languages have also the ability to tag a function with the kinds of exceptions that it can throw. TypeScript unfortunately does not have that yet. we covered the union type. There is also an intersection type. In an intersection type, you can say you have a house and a car, and the intersection type of house and car will have all the properties of house and all the properties of cars. This will become clearer once we go into classes, interfaces, etc., but know that it exists. However, if we try to create an intersection type of string and boolean, what does that even mean? If you hover over this, TypeScript actually infers that the type of this amounts to never, because a variable cannot be a string and a boolean at the same time. So yeah, there are some, you could almost call it Easter eggs hidden in TypeScript. And because the type is never, you can't assign it a true value, you can't assign it a string value. These cause compile errors. Now, we talked about using a never, and we talked about how TypeScript doesn't allow for a throwable or annotating what exceptions a function can throw. There's a cool GitHub example that I came across on Stack Overflow. I have the links for this in the GitHub repository. If you look at this code, you will see some mind-bending techniques with the intersection and union types to make a framework which allows for identifying the types of exceptions thrown by a function. Again, not recommended, but if you're curious. What is the value of a variable before it is assigned? For example, we have a variable here and we try to print it out, but TypeScript gives us an error saying you can't use it before it's assigned. There is an undefined type in TypeScript, and that is the value of any variable before it is assigned. So if we make a union type of number or undefined, then we can print the variable before assigning it, and it prints out as undefined, because the type of something that is not assigned yet is undefined. In our previous add example, instead of throwing the error here and using the never type, we could just get around the compiler complaining that sometimes we don't return any value by also using undefined as a union type in the return type. Then we just return here. We have to have this return because otherwise the compiler will complain that you have a function which only returns sometimes. But with a return here which doesn't return any value, your return type is sometimes number, sometimes string, sometimes undefined. Again, does this make sense coding this way? Definitely no. When a variable is not assigned, its value is undefined. But when a function does not return anything, the preferred type for that function is void. We can try calling a function that returns void. The result type as inferred by TypeScript is void, but if we log it, the value becomes undefined. And so in that sense, void and undefined are almost the same thing, but like I said, when a variable is not assigned, it is undefined, but in a return type for a function that returns nothing, use void. Then we have the null type. If you want a variable to not be assigned sometimes, then instead of using undefined, it's actually preferable to use null to be explicit that you deliberately intend this variable to not have a value. At the global level, outside of any functions, etc., you have to explicitly say the variable has a union type with null. But in a function parameter, etc., you can use this question mark notation to make a variable have a type which is, in this case, string or undefined. So you could call this writeLine function with or without this message parameter. When you call without the message parameter, message becomes undefined, and we handle that and print a new line. When you call with the message parameter, the message is whatever you passed in as a parameter. It must be noted that union with null is not the same as nullable. Here I'm union with null, but I still have a complaint from the compiler that it's missing a parameter. So I have to explicitly pass this null parameter, whereas the second one can be skipped because it is nullable. Similarly, union with undefined is not also same as nullable. Here, if I remove this undefined, the compiler still complains. In this case, the union with undefined requires that undefined to be explicitly passed, whereas for the second parameter, it can be skipped. Next, we will talk about type conversions, but here I'll go on a bit of a rant. Many people will show you tables and orderings of how conversions happen and things like that. Don't bother with it too much. My recommendation is to not rely on implicit type conversions and always to be explicit in all your type conversions. So let's look at how do we convert between types. For example, how would you convert from a string to a boolean? To convert a string or a number to boolean, you can use the not operator. So if you use the not operator once, it inverts the value. If you use it twice, it inverts it twice, which gives you the boolean equivalent of whatever value you applied the not operator on. So a double not operator converts to boolean. Now we said false, but when we convert that to boolean, it is true. This is because all strings except the null string are true in TypeScript. If you use the null string here, then that returns false because the null string is a false value. To convert to number, you can use the parseInt or parseFloat functions. The parseFloat can handle exponents, etc. as well. Finally, to convert to string, everything in TypeScript has a toString function. So you can use that toString method to convert whatever toString. Remember that if you have your own class, then if you do not override the toString method and provide an implementation, the toString will just give you object because it runs the underlying object toString method. In TypeScript, you have the any type to match the typelessness of JavaScript. A variable of type any can be assigned anything. You can assign it a string, you can assign it a boolean, you can assign it your custom class object, whatever works. Any can be assigned to other variables. TypeScript will not type check such assignment, so even if this was not a string but a boolean, this assignment will still work even though it doesn't make sense. That is where the unknown type comes in. The unknown type is similar to any in that anything can be assigned to a variable of type unknown. However, if you try to assign an unknown value to another variable with a different type, you will get an error from the TypeScript compiler. This can be avoided by explicit assertions. We will see them in a bit. So we have our any val here. It's of type any. What if we know that it's a string, let's say. So I'll make this a string. What if we want to print the length of this string? If I try to print length, I don't see it because this variable is of type any and any does not have a property length. So let's type assert this as a string. So then we have the length property and we can print out the length of that string. Another style of writing the same thing is the typecast syntax. If we run this code, the length of the string is 13. Now we mentioned previously that if we try to assign an unknown to another type, the compiler gives us an error. We can use the type assertion to get around this. Now the compiler accepts that because we are explicitly telling the compiler, yes, we know this is an unknown type, but we also know that the value inside of it is a string. If we print that out, we get hello world. Now instead of doing a type assertion, we can also do an explicit type check. When we do that, we are explicitly checking the type of any val to be a string. Now the string properties are visible on any val because TypeScript understands this if check and knows that inside of this if condition any val is a string. We can do the same thing with unknown types as well. If we run that code, both the any val and the unknown val print their length as 13. Here we are using the type keyword to define maths boolean as the type boolean. So maths boolean is now an alias for boolean, and I can define variables with the maths boolean type, and it will be a boolean variable. This is still an alias. Comparing to maths boolean will not work. My bool val has a type of boolean, and so you will have to compare it to boolean. Still, aliases are handy for abbreviating prolonged type declarations. For example, we have a function which takes two numbers and returns a number. We can define an alias for that. And then we can create a variable add alias, which is of this type. And we can assign the add function that we had above to it. Now if we do console.log add alias 4 and 5, we should get 9 because 4 plus 5 is 9. Add alias is a variable, so we can change the function assigned to it, and TypeScript will recognize that the type matches and this assignment is okay. Here we create an alias for the return type of our add function type. And so that will become number because add function returns number. And then we declare a variable using that alias and then assign a value to it and print out that value. In this example, this is fairly trivial, but this could be handy when you have complex types, especially when you're dealing with unions. And like I said, avoid it, but sometimes you can't avoid it. So we'll also do a quick aside on comments in code now. If you've noticed, I have copious amounts of comments above. It's not just for another person to understand, it's for me myself to also understand when I come back to this code after some time. And then one of the things that often goes wrong is keeping comments in sync with the code. Especially this happens in companies. I created a lot of code with good comments in there, and then a newbie comes along. He makes a change as a fix to some bug that he's assigned to fix, but he doesn't update the comments. Now the comments are out of sync. So don't be that person. Try to keep the comments in sync with the code. This is especially important in large projects. Next we come to arrays. You declare an array by using the square brackets. If we try to assign a value to this array, the TypeScript compiler complains that this array has not been assigned yet. So we will initialize the array using the square brackets again. This is the literal array initialization. You can also do a new array, which we will see later. And then we can make assignments of values. So here we are reassigning the myArray variable with a different array which has a size of 4. The parameter passed to the new array declaration is the size reservation. You don't need to pass it. Arrays can grow. So here then we are iterating 1 through 5 and assigning the index to be the same value as that index value. And then we print that out. So if we run this code, we will see 1 through 5 printed out, and then if we use the length property to print the length of the array, this prints 6. This is because JavaScript and TypeScript arrays start from 0, and so there are not 5 but 6 elements in this array, 0 through 5, and element 0 is undefined because we have not assigned it at this point. We can also assign values to negative indices inside of an array, etc. However, use negative indices with caution because it will lead to some weird behaviors which we will see later. Now we will use the array map function. This takes a function and runs it on every element in the array. So it'll run on all elements and multiply it by 2, so that our double array should have elements which are twice the value of elements in the myArray array. Note that the above is the same as this more expanded form where we have a function which takes a value and returns value times 2. So now let's print out the value of the fourth index of this array. That gives us 8. However, if we try to print out the -1 index which we assigned over here and we expect -2, we get undefined instead, because the map function does not know this -1 index. It only knows indices 0 through 5. Arrays have push and pop functions, so you can push a value and it adds another new index. You can also assign to indices out of order, so here we jumped from 6 to index 20. But now if you do a push, this becomes index 21 and not index 7. So index 7 gives undefined, but index 21 gives the 85 value that we pushed. To initialize the array, you can use an array literal. And so our element 1 is 2 here. You can delete an array element using the delete statement. So now we are deleting this element 1, and then its value becomes undefined. Because we can change or delete values, etc., we can see that arrays are mutable types. You can create an array of mixed type. It gets a union type designation. You can use the instance of keyword to check if something is an array. You can create a multi-dimensional array. Here you have a 2-dimensional array and we initialize it using a new array. However, if we try to assign these, even though the VS Code IntelliSense does not complain, if we try to run this code, we get an error saying we cannot set the property 0 of undefined. This is because even though the first dimension of the array has been initialized using this new array command, we have not initialized the subsequent dimensions. If we update the code to initialize the lower dimensions, then we can run that code, and this time it works correctly. Note that we are not printing any output, it just compiles to show that this is correct. Here we do not have a third dimension. TypeScript correctly gives us an error because we created this as a 2-dimensional array, but you could create multiple dimensions and make really big arrays. TypeScript has a somewhat weird notion of a tuple. Tuples are fixed length arrays with type constraints. So now here I have a 2-tuple with a string and a numeric member. So I can make a variable with which is assigned to an array with a string value and a numeric value. If I try to assign a different length array, you can do that. However, push still works, but there is no way to read the value we pushed, because if we try to do index 2, TypeScript complains that this can only have indices 0 or 1. We can use pop to read the value that we pushed though, but again, this is abusing the whole tuple idea, so I wouldn't recommend doing things this way. You can create tuples of other lengths. For example, here I have a 3-tuple. Again, why does this type exist? Why would you not create an object to capture your structure rather than use a tuple? I don't know. And so from an object-oriented programming perspective, I would recommend against using tuples altogether and instead recommend using classes and interfaces to capture this information. We can create an enumeration in TypeScript just like in C or C++. We can give initial values, so if we give indigo the value of 4, then blue will thereafter have a value of 5, whereas the initial value for is 0 by default. If you create a variable and then try to write the variable value, however, it prints 6, which is the value of the color and not the string that we would like it to print. But hey, our value for the enum can be a string and not just, and we're not just confined to numbers. So I could say red is red. In this case, I'm saying green is yellow, and then you can have mixed value types. So blue is 3, even though the other two are strings. And then yellow becomes 4 because blue is 3. If this blue was not here, then yellow gives a compile error because TypeScript cannot automatically assign another string value for this yellow. And now if we try to print this out, then the red value will be printed as red. You can also iterate through the various enumeration values in an enum. However, if we look closely at this, we see something surprising. We see our expected red value is red, our expected green its value is yellow, our expected blue its value is 3, our expected yellow its value is 4. But we also see 3 its value is blue and 4 its value is yellow. This is kind of a implementation detail quirk of TypeScript enumerations. Enumerations kind of get implemented both ways, so you have a set of mappings for the left side to the right and another set of mappings for the right side to the left, and then they get merged. In our case, 2 of the mappings, the red equals red and so green is yellow, but yellow is 4, and then 4 is yellow. We don't have a yellow is something. We don't have a yellow is green because that merged with yellow is 4 overwrote the yellow is green. But basically, this is a weird complex thing. Don't abuse it in your code. You can define an object using the curly brackets. And the previous one, when there is nothing in there, is an empty object. But now you have an object with 2 properties, x and y. You can use the in keyword to check whether a property is in an object. Note that you are not limited to using strings for properties. In this case, I have a number for my property index, and I can use that variable just fine. Notice if you hover over our object here, TypeScript inferred a type for our object. The type is identified by the property name and the type for the property. So the property name here is 234 and its type is string. That means we can use the type keyword to create an alias for our object type. For example, here I have an object type where there is a name, which is of type string. There's a value, which is a type number, and then there's a special value, which has to be the literal 42. It has to always be 42. Now we create a variable and assign it to a new nameless object of this object type. Here I have a string, a new number, and 42. But if I change this to 85, no can do. Or if I change this to true, no can do. Or if I remove one of these, that still doesn't work because the type has to match. Again, would you use this? My answer would be no. We will see interfaces later on. If you want to declare that an object has to have certain properties, you are advised to use an interface rather than using a type alias like this. Let's say we have an object with properties A and B. A is a boolean and B is a number. And we have a variable object X pointing to it. We create a new variable object Y and assign it to be equal to object X. And then we set object Y's A property to be false, object Y's B property to be 84. Now if we try to print object X's A and B properties, we get false and 84. So we see two things here. We are able to change an object's properties. So we set object Y's A, we changed it, we changed object Y's B. Also, changing object Y changed object X, which means object Y and object X are two variables both pointing at the very same object. So this demonstrates the reference variable thing as well as the mutability of objects. So X and Y are both referencing the same object and the object itself is mutable. If we compare that to strings, we can have two strings when we assign string Y equal to string X. At this point, both string X and string Y are pointing at the same test1 string. So in that sense, TypeScript strings are reference objects, but it never becomes a parent because you cannot do a string Y dot replace in place. This value becomes, so if you print string Y at this point, even though you replaced 1 with 2, the value printed will still be test1. Going back, we assign string Y is equal to string Y dot replace. This is because, like we showed, in-place replacements are not possible. So replace returns a new string which has the replacement made, and we assign it to the same string Y. At this point, string Y points to the new string, string X points to the same old string test1. So now if we print these two, then we see that string Y is test2, string X is still test1. So strings are also reference types like objects, but objects are mutable, strings are not mutable. Remember that we have our color enumeration up above here. So now TypeScript has this interesting concept, enum indexed properties. So here we have an object, but the object's properties are enum values. And this is legitimate. So if we create a function which accepts a color choice, then we can index out the corresponding string based on that color choice and log that. So here we are giving a green value, and that will cause green is my favorite color to be printed to the console. However, there is a question between should you use this or should you use a map here. We will see maps briefly in a bit, but we won't delve into that. Map is basically your equivalent of a dictionary. So again, there are quirks in the language. Sometimes these are useful, but sometimes there are better ways to do it. Be watchful of how you use the capabilities of the language. There are some very handy native object types in TypeScript and JavaScript. For example, we have a date type, so we can create an object of date. By default, it will be today's date, but you can pass a parameter for any particular date. And then if we print it, it will print the date of the date object creation, date and time. We already saw regular expressions earlier. We already saw arrays earlier, and there we used the new keyword to do a new array. There we are using the capital A array object type to create an array. And so there are similar title case types for number, boolean, string, etc. in TypeScript as well. I would generally say avoid these because why when you have the lowercase types. We also have a map type like we mentioned earlier. The map is basically mapping one value to another. So here we are saying string key maps to 42 and 85 maps to true. This is kind of a mixed bag of different types here, but we could constrain the map to be of specific types as well. So in this example, I have a map which maps string to string, aka a dictionary. So I can say key1 maps to value 1, and then if I get the key 1, that prints value 1 here. We will not go into a lot of detail beyond this about native object types, but this developer.mozilla reference on JavaScript is a very good reference for native object types. You can find this link on my GitHub code base in my GitHub repository. If you remember, at the beginning of this tutorial, we installed ESLint as well on this project. So if we run lint now, you will notice a whole bunch of errors. That's because we wrote this code as kind of a write along of a whole bunch of things, and we have created variables using let where we don't use those variables or reassign them later, etc. So if you look through these errors, you can see a lot of useful information. Right now we are going to ignore these, but something to note that ESLint can be really handy in catching a lot of errors and helping you keep your code clean. So I will highly recommend using a linter with your code. We went through a lot of content categorized under the general heading of basic types in this tutorial. In our next tutorial chapters, we will go through operators, decisions, loops, functions, modules, classes, interfaces, generics, etc., which will build upon all of these concepts. So even though it was kind of a haphazard explanation of all of these concepts, practice them. We will use and build on top of them later. And keep an eye out for future videos. Like I said, the topics that we will cover. Like this video if you found it useful. Subscribe to the channel so you are notified about future offerings, and I will see you in the next video. If you have questions or concerns, feel free to drop a comment. I will do my best to respond to them as quickly as I can. All of the code that we used in this tutorial is available from my GitHub repository. I will post a link to this GitHub repository on this YouTube video as well. See you on the next YouTube video.